Hey everybody, this is Chapter 6, Section 3. Title is Solving Systems Using Elimination. Starts on page 374. This is the third different way we can solve a system. Most people in general think that this is the easiest one, so I hope that you agree. To eliminate means to make something go away. So that should give you a hint as to what you're trying to do in this type of problem. You're trying to make something go away. In fact, you're trying to make one of the variables go away. These problems all have x's and y's, so it's like you're trying to get rid of all the x's in the problem. So you'll only have y's left, or you're trying to get rid of all the y's, and you'll just have x's left. When you're using elimination, the key is this. You're looking for variable parts that are the same. For example, 4y and 4y, those are exactly the same. Or you're looking for variable parts that are opposites, like positive 3x and negative 3x. Those are opposites. If the variable parts in your problem are the same, you're going to take the two equations and subtract the entire equations. Okay? Take the first equation, subtract the second one from it. The way that I remember that is because same and subtract both start with s. So that's how I remember that same and subtract go together. If the variable parts in your problem are opposites, you're going to add the equations together. Okay? And I remember that one because opposite and add both start with vowels. Okay? So that'll help you remember which one you're supposed to do for which type of problem. Okay? So the keys, you're looking for things that are opposites. You're looking for things that are the same. Okay? After you've eliminated one of the variables, you should have one variable left. Solve for that variable, just like you did in the substitution lesson. Remember, the solution of a system is supposed to be an ordered pair. After you solve for one of the variables, plug whatever that is back into one of the original equations. It doesn't matter which equation you pick. And then you're going to solve for the variable that you haven't done anything with yet. Just like last section. If you found x, you plugged x back in, and then you had to go back and solve for y. Okay, so same type of thing in this section. Here's an example. Use elimination to solve this system. Now, remember, we're looking for same or opposite. These pieces right here are opposites. A negative 6y and a positive 6y. Those are opposites. Remember, opposite means add. So I'm going to add these two equations together. So I do 5 plus 3, and that gives me 8x. Negative 6 plus 6. Remember, we said those were opposites. When you add opposites, they cancel. So those go away. Negative 32 plus 48 gives me 16. So I added the x's, I added the y's, and I added the plain numbers. And this is what I get. One of my variables, the y's, disappeared. They were eliminated. Now I have to solve for x. Divide both sides by 8. And I get x equals 2. Remember, that's only half my answer. I have an x, now I need to figure out what a y would be. So I'm going to take that and plug it into one of my two equations that I started with. It doesn't matter which one, you should get the same answer both ways. I'm going to pick this bottom equation because it doesn't have any minus signs in it. So instead of x, I'm going to plug in a 2. Okay. Do a little simplifying. 3 times 2 is 6. And now I'm just trying to get the y by itself. Subtract 6 from both sides. Divide both sides by 6. Y equals 7. So now I have my ordered pair, 2, 7. Okay. Example problem here, just like the one that I just did. These are opposites, so I'm going to add, and I'll let you do the rest. Okay, next example. Still using elimination, still looking for opposites and things that are the same. So here I have two pieces that are exactly the same. Remember, same means I'm going to subtract the equations. So 2 minus 2 equals 0, so that piece goes away. 3 minus 5 gives me negative 2y. 130 minus 190 gives me negative 60. Okay, again, the piece that's the same or opposite ends up canceling out. It eliminates that variable. That's why we look for those things. Solve for y. Divide by negative 2. Y equals 30. Okay, there's half my answer. I can plug it into any equation I want. This time I'm going to plug it into the top one. So instead of y, I'm going to write 30. Three times 30 is 90. Subtract 90 from both sides. Divide by 2. And I get x equals 20. So my ordered pair is 20, 30. This problem, I had two things that were the same, so I subtracted the equations. Your practice problem, same thing. These are the same right here, so I'm going to subtract these two equations. I'll let you keep going. Sometimes the variable parts that they give you, they're not the same and they're not opposites. So you're going to have to do something to them. You're looking for things that would be easy to multiply. Okay? It would be easy to multiply one of the equations to get something that's the same or opposite. Okay? Remember, if you're going to multiply an equation by something, you have to multiply the entire equation. Here's what I mean by that. By the way, there's a typo here. Let me tell you what the correct problem was supposed to be. (5x minus 6y) plus 6y equals 17. Negative 10x minus 9y equals negative 43. Okay, I just put the wrong problem up there. The one that I gave you wouldn't have worked. So here's one that will. Now, I don't have anything that's the same. I don't have anything that's opposite. Is there a way I can I multiply one of those by something that would make it either the same or opposite? Okay. Now look, I have 5 and I have a 10. Okay. Can I multiply 5 by something to get 10? Sure. I can multiply it by 2. But I have to multiply the entire equation by 2, not just the 5x part. Okay. If I multiply that top equation by 2, I'm going to get this new equation down here at the bottom. So 2 times 5 is 10x. 2 times 6 is 12y. And 2 times 17 is 34. So now I have this new equation. Now, look at these two. These are opposites. What do I do if I have opposites? I add. When I add opposites, they cancel. So that turns into 0. Negative 9 plus 12 is positive 3. Negative 43 plus 34 is negative 9. My x's went away, they were eliminated. Solve for y. Divide both sides by 3. Y equals negative 3. Okay? That's half my answer. Now I take that and I plug it into one of the two equations I started with. Okay? Not this one. That wasn't one I started with. I had to multiply to get that one. Okay, so I'm not going to do that one. I'm going to do one of these first two. Doesn't matter which one. I'm going to plug it into the top one because there's less negative signs in that. So 5x plus 6, and instead of y, I'm going to write in my negative 3, equals 17. Positive 6 times negative 3 is negative 18. Add 18 to both sides. 5x equals 35. divide by 5, and I get x equals 7. So my ordered pair is 7, negative 3. Okay? So you were looking for something that you could multiply one of the equations by that gave you something that's either the same or opposite. And it's easy to multiply my 5 by 2 in order to get 10. Then I had two things that were opposites. Okay? Here's yours. Take a look at it. There's nothing that's the same. There's nothing that's opposite. But is there something I can multiply one of those equations by to get something that's the same or opposite? Okay, next one. Sometimes you can't just multiply one equation in order to get something that's the same or opposite. Sometimes you have to multiply both equations, okay? This should kind of make you think of things like least common denominator. In this problem, is there anything I can multiply 3 by to get 4? No, there's not. Is there anything I can multiply 2 by to get 3? No, there's not. So I'm going to have to multiply both equations. Okay? Let's look at the 3 and the 2. What number do I get if I start looking for a least common multiple there? Okay? The first thing I get to when I use a 3 and a 2 is a 6. Okay? So what can I multiply this equation by so that I end up with 6y? Well, in order to get 6, I have to multiply this equation by 2. Now, on the bottom equation, what do I have to multiply by in order to get 6y? Well, I'd have to multiply this one by 3. Okay? The reason why I do that is because now if I multiply both of those equations, 2 times 4 gives me 8x. 2 times 3 gives me 6y. And 2 times negative 19 gives me negative 38. Okay? The bottom one, 3 times 3 gives me 9x. 3 times negative 2 gives me negative 6y. And 3 times negative 10 gives me negative 30. Okay? The reason why I multiplied both of those equations is so that I would get something that was opposite right there. See how those are opposite? Now that I've done that first step, the rest of this problem is going to be just like stuff that we already did. Okay? I have opposites, so I'm going to add. Eight plus 9 is 17x. If I add the y's, they cancel out, they eliminate because they're opposites. Negative 38 and negative 30 gives me negative 68. Divide both sides by 17, and I get x equals negative 4. Okay? Just like before, I take that x answer, and I plug it into one of the two equations I started with. Okay? I'm going to plug it into that top one. Remember, when I started, there wasn't a 2 here. So I just plug it into that equation like it looks there. 4, and instead of x, I'm going to write minus negative 4 plus 3y equals negative 19. 4 times negative 4 is negative 16. Add 16 to both sides because I already have a minus. 3y equals negative 3. Divide both sides by 3, and I get y equals negative 1. So my ordered pair is negative 4, negative 1. Okay? So sometimes you have to multiply both equations in order to get something to be either the same or opposites. This one's yours. Is there anything I can multiply 3 by to get 5? No. Is there anything I can multiply 8 by to get 9? No. So I'm going to have to multiply both equations. Okay? I'm going to multiply both equations until I get the x's to be 15. That's a little hint for you. Okay? In order to get 15 for the top equation, I have to multiply by 3. because 3 times 5 is 15. For the bottom one, I'm going to multiply by 5, because 5 times 3 is 15. I'll let you keep going from there. Just like the last two sections, you can get one solution, no solution, and infinitely many solutions. Just like last section, in order to get one of those special cases, your variables have to cancel out. If the variables cancel and you get something that's true, that's still infinitely many solutions, just like last time. If the variables cancel and you get something that's false, the answer is no solution, just like last time. Okay? So here's one of those. Again, I had a typo, so let me fix it real quick. This is supposed to be 5x plus 3y. Don't forget to change that on your paper. And it's supposed to be 20 instead of 10. Okay, so that first equation is 5x plus 3y equals 20. Now, do I have anything that's the same? Do I have anything that's opposite? No, I don't. Can I multiply 5 by something in order to get 10? Yeah, that's easy. I can multiply by 2. So 2 times 5x is 10x. 2 times 3y is 6y. 2 times 20 is 40. Okay? If I look here, I have two things that are the same. Same means subtract. 10x minus 10x is 0. 6y minus 6y is 0. 20 minus 40 is negative 20. Now, all of my variables went away, and I got something that's false. If I get something that's false, that means my answer is going to be no solution. Here's yours. Again, is there anything I can multiply 2 by to get 6? Yes, there is. If I multiply 2 by 3, then I get a 6. Okay? I'll let you continue from there. Questions, comments, and concerns? We should have quite a bit of time on our next class period to go through those that you have. Don't forget, next class period you also have time to make up old quizzes as well, since it's a block day.